Be completely frozen today. Today's warm compared to what tomorrow's going to be, unfortunately. So we have a lot of stuff to cover. Hopefully this week we'll not have snow days. That's what our hope is.
Maybe not a snow day, but a cold day.
I doubt we will close for a cold day. I have not seen that before. So it could be. I doubt it. I want to think positive that we're going to be here because it's wonderful weather. And we're better to hang out than in a nice, warm classroom. All right, so a couple of things as we go through here. I had about 80% of the people turn in the homework. Here's the problem. I cannot and will not take late assignments in this class. Once I go through and I pop a solution in, that's certainly not fair to those of you that did the work or managed to do it. If you know ahead of time that you have something going on, I can sometimes find an alternative assignment. But this class, we really just can't do late assignments. So just a reminder on that. So this week we start in on something that I think is what the most powerful piece of a computer actually is. That ability to loop and do things over and over and over again. And so we're going to look at some of these, and we're going to look at a couple of items that I think are kind of exciting. But let's look at our homework first, and we're going to go through and look at that. So at the bottom here of week 4, you'll see we have some solutions. So the first part of your homework was looking at those Boolean expressions. So we started thinking about, I need to do comparisons. What kind of comparisons can I do? And so the other piece we need in here is we need to figure out what those are. So we say number red equals number blue. So what's number red equal to? You remember?
100.
So we have 100 equals, what's the other value? 200? Is that true? No. Hopefully we know that 100 doesn't equal 200. So that one's a pretty easy one. That should be false. Number blue greater than number green. So false again. Number green less than number red. So false. But then we get to this one. So what's the value for number blue? Number blue is, yeah. So you have a number and you're trying to compare it to a string. Can I directly do that? No. So in this case, we say it's illegal. So number green equals, and we actually put in a value equals green. Now, here's the weird reality. Most programming languages, they're either going to say, hey, you've got an illegal comparison, or even worse, they might make the comparison. You think, well, how is it going to make a comparison between 100 and blue? Well, remember, inside of that computer, everything is a number. And so blue is a set of numbers. And so it would then try to take, in some programming languages, take whatever value is in there and actually utilize that. So we have to be careful with those. All right. So number red is less than or equal to number green. So we have a couple of trues. So the only ones that really you should have come up with that are illegal are D and E, because we're trying to compare two different things. So we're trying to compare a number and a string, and that's where we generally can't do that. So these get a little more complicated, the last couple. So number red equals 100, or number red is greater than number blue. And so those we might need to write out a little bit so that we make sure that we actually have that correct. So I'm going to write out a couple just so we can see how that would work. Because it really does take a little bit of thought on some of these. So Notepad. So we have, thank you very much. So in Notepad, we're going to just take this expression from, let's do K. So it says number red is greater than or equal to number blue. So what's the value for number red?
100.
Okay. And so we're saying that is greater than the value of number blue, which is 200, I believe, right? And number blue, so that's our 200, is less than number green. And what was the value of green? 300. So the way to solve these, when I look at that, I have to actually evaluate each piece separately. So the first thing I have to do is 100 greater than 200. I hope not. So we have false. So 100 is not greater than 200. And is 200 less than 300? True. And we're doing an and. So in an and statement, can any portion of it be false? No. And so if that's the case, that whole equation says, nope, we're false. And so that truth table, so we looked at those truth tables in there. So both portions of an and statement have to be true to evaluate as true. So the only way this would work is if both sides were true. So true and true equals a true. A true and false equals a false. A false and true equals false. And hopefully false and false equals false. So that's where those truth tables come in. We have to actually work our way through some of those values. So those are the ones that most people, when I look at, they get wrong because they go through here and they just look at a piece of that and say, well, one portion of that's true, so that whole statement's true. So let's do one with an or. So let's do number, let's do M. So number green, so our number green is 100, I believe, correct? So what we're saying is 100 is less than 10. Or, what's the value for number blue? 200 is greater than 10. So we're evaluating this. So we have to evaluate each portion of it. And so is 100 less than 10? No. Or is 200 greater than 10? I hope so. So now we have an equation where we have a false or true. And we can do the truth table for ors also. So T and F. So one true and one false equals true. False and true equals true. So that's our truth table really quickly for an or statement. By looking at that, I can say, well, one portion of that is true. And that's really what that or statement is telling you, is that one or the other of those statements has to be true. In this case, one of those statements is true, so the entire equation evaluates then to true. So those compound ones get a little trickier. It's even trickier the very last one. So the last one actually has two compound statements in it together. So let's work our way through that one. I'm going to clear out the screen a little bit. So this last one, number n says number blue equals 30. So that is an equation. Is number blue equal to 30? Well, we know number blue is actually, what value is number blue? Is that 100?
200.
200? All right. I don't have those in front of me, so we're going to say 200 equals 30, and number green, that's the 300, I believe, equals 300, or number red, if I have that correct. So we have 3 statements in this one we have to deal with. We have 3 statements in there. And in our book, there's an order of precedence. Do we do an and statement or an or statement first? Do we do ands or ors first? Because this is a new precedent. We have not had to deal with both of these together. And in your math classes, you probably didn't worry about the order of Boolean operators. But let's break this down first and put in what we know that is. So is 200 equal to 30? So we could break this down, and is 300 equal to 300? I hope so. Or is 200 equal to 200? So we have our equation broken down a little bit, but we need to figure out if the entire equation is true. So what we can do is we can look at this equation and we can try to figure out whether it's true or false. We have false and true or true. So we need to go up and we need to say, well, I don't know what the order of operations Boolean might give us a hint. Your book also has that. And you can find there's that and takes precedence in or in most statements. So, in fact, in some maybe it's a not. So we need to figure out which way that would go. So there's a lot of resources out there, including our book. Because right now, what do we think it is? How many of you put false down? How many of you said true? How many of you didn't do the homework? Just kidding. How many of you put false down for this one? Number in the last one. Or, letter N, sorry. So, for the problem on N, so, correct. So, if I rephrase that a little bit, so if I put parentheses around there, it might make more sense. So if I broke this down and I eliminated that or, so what is that? Is true or true? Is that true? According to our truth table? Yeah. So now what I'm really saying is that false and true, does that evaluate to true or false? And that evaluates as false. So that one is a little more complicated. When we start stacking these things together, it gets a little more complicated. When we start writing those statements in code, those get a little more complicated. So that is these in a nutshell, the Boolean operators. We use them all the time. It's helpful to remember these truth tables. The other way to remember it is you can always think, well, everything has to be true in an and. Something has to be true in an or. It doesn't matter which, but something has to be true in an or. In both of them, if everything is false, it's always false. So the next piece we wanted to look at there was we had a little bit of an assignment about we're trying to find out some information about a phone call. And what I noticed is Some people, for whatever reason, didn't do A and B. They did kind of a combination of A and B. So I had a little bit of a discrepancy there. The other piece that we need to make sure that we are doing is that we are indenting blocks of code so that we understand what happens in there. So we're going to actually clean this up because this is kind of ugly and doesn't do everything we want it to do. So I'm going to copy this into my notepad. And I'm going to start down here and make a brand new one. So when I look at this, there's a lot of things that we know we need to do. So I know that the start and the end are on one level of indent. The rest of the code needs to be indented one line in to start with. So I can do that. And there's some ugliness here because it's not quite all in line, but I'm not too worried about that. I want to see where the indent blocks go. And then we'll work our way down here from that. Alright, so the first thing we have are our declarations. So we've worked through the problem. We know that we need a couple of things. We need a area code, phone number, area code, and a called number. All right. We need minutes, in other words, how long you were on the phone, and we need a price. So, a couple of things we need to do in here. One of them that I don't like in our book and most of the solutions, what is it not doing when we declare something in there?
It's not setting it equal to something.
It's not setting it equal. And so my preference is always to set it equal to either a value that we're going to use or a 0, just so we know that there isn't any garbage in there. And that starts to become an issue when we start using these as modules inside other programs. That value may have been used, or that variable, and so now we set some values in there. So that's all in one. This is a sequence of operations. Happens. We do each step line by line by line. And then we come down here and we do a little shortcut. We input all of these items together. And so we input that customer area code, a phone number, called area code, called phone number, and minutes. So we get all these pieces, and they broke that number up. Could we really have just said input phone number and then looked at the last half of it? Yeah. But this maybe makes a little more sense because we have the area codes separate to start with. Because the area codes are how we determine the price of that phone call. So, area code, phone number, called area code, called number, and the number of minutes. So our billing software is pretty smart now. It's got all this information in it. We have an if statement then, because what we want to know is if our area code is different than where we're calling from. And that's a weird thing in our tariffs and how we pay for phone calls. It used to be every time you picked up a phone, it cost you money. Now with cell phones, does this matter as much? No. But the phone companies on the back end actually keep track of that. So they settle up with each other about who owes who for phone calls. So we have an if statement. So if customer area code is not equal, so the other way we could have wrote that is we could have said that, not equal, is not equal to called area code. So in other words, those are not the same, so it's a long distance call. So our if statement automatically says we have to indent that. So this block of code is going to run in this if statement. But we have something else going on. What have we actually put inside of our if statement? We actually listed another if statement, didn't we? So this needs to actually be inside of there. So if minutes are greater than time limit, then this runs, else, and so notice this else and this if are at the same indent line. So whatever's in this block of code will run if this statement is true. So else price equals, all right, so this end if then, so this all says this is one block of code inside of this if statement. This level says it's a block of code inside of this if statement. So we check, we say, all right, if the minutes are greater than our time limit, then price equals minutes times the low rate. So in other words, if you talk longer, you get a low rate. Else price equals minutes times high rate. So low rate, high rate. So based on 20 minutes. Now here's our if statement. So this really is indented in this block of code. If it's equal to, then we do all these. So what is the problem with this, or what does this do wrong? Do we think? So if it's not equal to color code, then, so what does this do if we're at the same area code? What does it do? It just kind of dies, doesn't it? Because if we're the same area code, none of this runs, right? So if the area code and the called area code are the same, then we don't have any mechanism to charge them in this particular problem. But when we don't indent and we don't show that block, it's hard to see what's going on. And more importantly, your program's not going to run in most languages. Most languages rely on those blocks to be indented. So it says, all right, if I have an else statement, this block is going to run. So we need to make sure you do the indents. So I had a couple of people decide to turn in, instead of using text editor, or they may have used the text editor, but they tried to just turn in the assignment in that little text box in there. And that doesn't work because it loses all of those indents. So this week I made a big note, make sure you turn it in as a text file, whatever it is you have. So let's look at part B and see if we can do something similar to it. So part B, put that into a text editor. So what did part B want us to do? They didn't want us to do anything different?
It says it wants a program that accepts data about a phone call and displays all the details only about a call that costs over $10.
Okay, so we have some similar details, but now we only want to deal with a call that's over $10. So this time, I'm going to move those out one indent just so we can start on it. So we have our business information. We have the same idea. We have rates, 10 minutes, or 10 cents a minute, 13 cents, time limit of 20. So our program looks very similar. So we input these items. This input isn't probably somebody saying, hey, I just made a phone call. It's input coming out of a data file off the phone company, maybe something out of a telecom system. So we input all that same data. So we know what some of those prices could be. So if area code not equal, so this logic is still the same. So then price equals minutes times low rate, else price equals minutes times high rate. So either way, we're going to guarantee here a price of some sort. Unless what? What happens if they're the same area code? And so we can put in a value and we can see. So let's just say, hypothetically, we're in the 402 area code and we're dialing somebody in 402. So my customer area code becomes 402. And my called area code is 402. Let's work through and see what happens in this program. So input. So we got those values. So if 402 is not equal to 402, so what is that going to equate to? So what you're asking is 402 not equal to 402. Then you have an AND. So is 402 not equal to 402? Is that true or false?
False.
So it's going to be a false. So we could replace that with our false. We didn't ask how many minutes there are. So let's say our call was 30 minutes. So that's minutes are greater than time limit. So 30 greater than 20. And so hopefully that equates to true. So I have a false and a true. Is that entire equation true or false? So a false and a true lead to what? False. So this whole thing is false. So if this is false, this piece isn't going to run, is it? But this one will. So if this is true, this runs. If it's false, this runs. So we know then that we need to put in our price is going to be 30 minutes times the high rate of 0.13, or what would that be off the top of my head? $3.90. So price is now set to $3.90 for a phone call. We come out of our if then else statement and we have another if statement. So if price is greater than $10, then it's going to output customer area code, all of that information. So here we're saying is $3.90 greater than 10. Hopefully we see that as false. So we don't output a price at all in that particular scenario. That's that idea of doing that desk audit. So we don't output anything. Does that make sense? So if I change this just a little bit, so if instead of $3.90, that's a $39 phone call, then this would change that a little bit. So $39 would be greater than 10. And then we would output the amount of their phone call. And I know this is a little strange because we're all used to the idea of phone calls are free. But it doesn't take long to accumulate $39 phone calls. And you're thinking, how does that happen? Think about here at our college. When you dial into the college, what number do you dial? Do you just dial the 800 number you find on our website? 800 numbers still cost our college, I think it's 23 cents a minute. So we actually pay a significant amount here at the school for phone lines. Landlines, especially for businesses, are still very expensive. So not germane necessarily to that, but when you think about phone lines, a lot of us think, why am I worried about what it's going to cost anyway? But when you dial from Verizon to US Cellular or another carrier, they do keep track of this. Even though you don't get a bill, the customers, though, so US Wireless and all these companies bill each other back and forth in the background. And you don't see it. It's just kind of absorbed into your phone bill. So those are a couple of possible solutions. Are those the only possible ways you can do it, and it has to look exactly that way? No. You will need some nested if statements to get through there, but you do not need to have it look exactly the same. So when I go through there, I actually do kind of that desk audit, like what I just showed you, is I put in a couple of numbers in there, and I work through your logic and try to see if what you've done makes sense. And so that's where we end up with that. So that is kind of a really quick overview of a solution for those and different things we can do. So a couple of things. So most of you have used Excel. So these similar types of things you could actually do in Excel. So notice if I type equals, that says I'm going to create a formula in Excel, right? Excel always likes this idea of a formula. So if I type equals and I type if, notice it actually says it's got this statement in it. So if checks whether a condition is met and returns one value if true and another value if false. So we could actually do something with that. So I'm going to put a value in here of 100, just because I can. So we can actually use if statements inside of Excel. So the same things you guys just did with that phone thing, you can actually do. Oh, put a value in here. So it says, oh, there's a problem here. So if statements have a couple of different pieces. So we have to have a value, a logical test. We have to have a value if true, and an optional value if false. So I'm going to say is that value greater than this value, comma, and if it's true, I'm going to output true. So the other thing you can do is when you build something like this. Oh, I did something weird here while I was trying to type. So it really is, so it puts in parentheses those three sets of things you need. So if my first piece is true, it's going to output a number or a value. So here I put it out true or false. So you can do it for a lot of things. So here it says I'm comparing 100 to 200. Well, let's put in 201. So is 201 greater than 200? Yeah. Here's where we run into problems. And so this is kind of a good test to be able to build those. So if I put in 200, what do you think is going to happen? Is 200 greater than 200? Let's see what happens. It says false, because 200 isn't greater than. Now, could I change this to have a greater than or equal? So if I change that to a greater than or equal, then it could do that. So let's change this up just a little bit in Excel. So let's take this value. So we're going to look at another value. And we want to figure out if you're going to get an A or not in class. So I'm going to just rewrite this just a little bit. So if H5 greater than 0.9. I'm going to output an A. And in this particular class, I'm pretty rough. It's either A or an F. All right, so I need to put a value in there. And so that value I'm going to put in is you worked really hard and you got a 0.9 or a 90%. Whoa. You got an F, right? Because we didn't say equal to, it's not greater than a 0.9. So we need to change that a little bit. So we're going to say greater than or equal to. So you get an A now. Great. Here's the fun thing about Excel. Now I can copy this down, this formula, if I wanted to. And I could put in all kinds of grades. And now I can put in and figure out what your grade is. So this way I'm not biased. I can just slip in a grade. But how do I do it with multiple grades? Is there a way I can add in to get a B in there? I really want to be nice. And I want to say, you know what? You can get a B. It's pretty easy to do. So what I can do is I can actually nest these together. So if you don't get an A, we're going to take another test at it. So you're going to say if, and then we're going to say if that cell H5 is greater than or equal to 0.8, which would be a B, so notice we're just nesting that right inside there. And there's our F. So now we can try this. And so I can post this back in. We can load some values in to see what happens. So let's do a 0.85. And notice now it's got a B. And it works that same way. It first searches through there, pulls out all the A's, then we look for the B's. And so we could nest this together. It gets a little ugly. But you could nest that together to get all of the grades in our grade book, right? Yeah. And that's actually what I've done, is I take your Excel or your grade book out of Blackboard and I run it through something like this so that I can make sure that it actually comes out right. So we could make a formula, and we're just nesting those if statements. So if I looked at it on our pseudo diagram, so what you're really saying is you're saying if grade greater than or equal to 0.9, then grade equals A. Else, if grade greater than or equal to a 0.8, and notice because those are indented, so now grade equals a B. Else, and that's where I could either say grade equals C or lower, or I could then do another one. So I could say if grade greater than or equal to 0.7, grade equals C, else if grade greater than or equal to 0.6 for our D, grade equals D. So there I've nested 4 layers deep just to show you what we can do with that. So we're nesting those things in those if, then, else statements. So there's some other ways, and we'll show you how we can do some of those a little later. But that's one way we can do it. In fact, it's pretty easy to write. It just gets a little confusing, so you got to make sure that you're in the right portion of that the entire time. So that's the same way I could create logic here and do that in Excel. So that's something we don't show you in Excel, that you can actually do those same logic statements. So you could have, quite frankly, created this to test out those logical values in there. And it will tell you if it's true or if it's false. And in fact, if you leave out, let's see what happens here. I have not tried this with the latest version. Greater than 9. Apparently it makes you forces you to. It used to just show you, it would just pop out a true or a false if you just did that. But you could do the same thing, because what you know is if it evaluates true, then something's going to happen. So there. One of the things is to make sure, if you want to output text, to make sure you do it with a quote marks in there. And so now we're just reflecting a true or a false. It will take ands, it will take ors, it will take all of those together. And so we can actually work some pretty convoluted logic, and you can use Excel as a way to do something. So if you wanted to do something exciting in Excel, you wanted to have it start doing some Boolean logic, you can actually do that inside of Excel. So we want to look at that idea of a loop. And there's a lot of things we can do. I'm going to jump through this. The loop is what makes our world, if all I did was a sequence, I could repeat it and I could do copy and paste. So I go through and I search for grades. I could loop in that way. I could say, well, I'm going to do it 500 times. I can copy and paste 500 times. That's not very efficient, though. Because if I don't need it all 500 times and I've copied and pasted it, then it's going to sit there and run needlessly. What if I have 501 grades? It's not going to necessarily work. So loops are how a computer becomes efficient and how it adds value to a lot of things. So a loop is great. It's got a couple of things we need to be very careful of, though, with a loop. So in our loop, we always have some way to control that loop. So either we use a counter or some kind of a sentinel value. We have to control how many times that loop happens. Now, we may want that loop to continue, and based on a condition, we may want it based on a counter, we may want it based on something else. But we need some way to control that loop. So think about our thermostat in here. Do we want our thermostat to only check the temperature once a day? And then it'll never turn the heat on again if it doesn't check. That's okay? All right. Normally, we want it to keep checking. And so while that thermostat is still calling for heat, it's going to continue to run. So it's using some kind of a sentinel value to control this loop. So while loops have a couple of pieces in it. So we're going to initialize that. So a lot of times it's similar to that priming the pump. We have something that happens ahead of the loop. We have something that happens in the loop to change that variable, or at least test it. And we have some way to alter that loop condition. If I don't have the ability to alter that loop, then it's going to run forever. And so we have that term, endless loop. So here's an example of a loop. And this one actually works pretty well. So if we look at the flow chart, we have our start and our stop, and then we have our declarations. So we're going to set count equal to 0. So we very clearly put a value in there so that we don't get outside of those bounds already. And so we ask that question, is count less than 0? If count is less than 0, Then we output hello. We say count equals count plus 1. So in other words, we add a value of 1 to that counter. And then we come up and we check it again. Notice our loop goes up at the very top of our decision, and that's the only place it can go. So if we come up, we test it again. So the first time through, 0 is less than 4, true. It runs, it outputs low, it adds 1 to that. So now it's coming up as 1. Comes up, we check it again. 1 is less than 4, it outputs hello, adds another one. So now our count is up to 2. 2 is less than 4, so it outputs again. Adds 1, so now we have 3. 3 is less than 4. It outputs hello again. Now count is 4. Count is equal to 4. Comes up there. Is 4 less than 4? I hope not. So it exits out and our program is done. So it's interesting though, our count, so if we would have changed that simply to say less than or equal, we would have actually printed 5 times instead of 4. So one of the things we always have to remember, when you start counting, what do you start with? We start with 1. The computer always starts with 0. And that 0 says that this will actually work. Even though we're saying less than 4, it's only going to run 4 times. If we look at the pseudocode for this, so declaration, so we declare that to 0. While count is less than 4, output hello, count equals count plus 1, end while. That seems pretty simple. That loops 4 times in this particular case. Now, I will say there is one thing that I do not like about this. What do you think I don't like about that short little pseudocode or the flowchart? Well, it would be something that looks like we don't want. We called them mystery something in the last chapter. Mystery numbers. So think about this. So we say while count less than 4, could we make that a variable? Sure, you could say number, so you could say have a counter, you could say number of output or whatever you want to call it, and then you could change that at any point. Those mystery numbers, when you start looking at a longer program, get to be an issue. But in this case, it makes sense because we can see that it's less than 4. We're going to run that. So we can control that loop in a couple of different ways. You can do it like we did by increasing it. We could have started at 4 and decreased it. So we have some items. So when we know how many times a loop is going to go. So there we set up a loop with a definite number of turns. We know that we wanted it 4, we wanted it 6, we wanted it 8. It's called a definitive loop or a counted loop. And we know exactly how many times that loop is going to run. So there's a lot of times that makes sense. A lot of times. We want to output something a certain number of times. We want to get input from a certain number of users. So think about down at the football field. Everybody's going in the gate. Every time we go through the gate, we take one number off the people that we have we can see. When we run to 0, then we'll pop up a sign that says, nope, no more people allowed in the stadium. I don't think we've had that issue yet, but it'd be nice someday. But we have a concert coming up, don't they, in a week or so? A couple weeks? Is it 2 months away? Oh, it's in March? March is next week to me. So March is coming up. You have a concert. You have so many students in there. When that AWAC Center is full, are they going to let more people in there? No. Some of you have probably been to nightclubs where they do that. They've got the little hand counter. Well, we're doing the same thing. We're counting to see how many times we can cycle somebody through. So if we don't know, if it's a definite loop, how many times we're going to run it is known. So if it's an indefinite loop, we don't know how many times it's going to run. I don't know how many times tomorrow that thermostat is going to call for heat. I bet it's going to be a lot, but I don't know that. And so I can also write a loop. I can write a loop that will do something a little more complicated. All right. So you have to hang with me. This one's on 2 pages. So this one is using a Sentinel value, and so we'll show you what that is. So let's look through this really quickly. We're going to have a bank balance program. Everybody likes to have a bank balance, right? A big bank balance would be better. A big bank balance that doesn't have that negative sign or comes out in red would be even better, right? So we're going to declare a couple of variables. So we have bank balance, interest rate, some kind of response in a string, and an interest rate of 0.04. I would love it if the banks would pay 0.4 interest or 4% interest, right? What does a bank pay on your savings right now? 1 or less? Yeah, it's pretty sad. So, very first statement in here says output. Enter your starting balance. So in other words, now we're adding some more details. So we could have just said input bank balance. Now we're saying, we're putting some text in there just to say, hey, go ahead and tell me what you're going to put in there. And then it outputs, do you want to see your current balance, yes or no? All right. I kind of want to see what I've made today. And so we now come in. If you said, no, I don't care about my balance, this program's pretty easy. And it says, have a nice day, go away. On the other hand, if you put in yes, you'd like to see your balance, it's going to say output bank balance is, and it's going to tell you what your balance is. But the next step is where it gets interesting. It takes your bank balance and adds an year's worth of interest. So it says bank balance equals bank balance plus bank balance times interest rate. In other words, we're going to add 4% to your bank balance. And then it says, hey, do you want to see next year's balance? Okay. And we wait for it to input a response. And if it's yes, it will output next year's balance. And then it computes another year in the future and says, do you want to see the next year? So this, you could go as many years into the future as you wanted to, seeing what your bank balance would be. All right. Well, this would be very similar to, and you would just be getting that value out. Could I do the same thing in Excel? I can't necessarily do the loop. We can, but we're not going to in this one. But let's say we have a healthy balance. So you're just looking at it, and your balance is $1,000. Because the other piece I want to think about is how we write that statement in there. So that's year one. That's when you first come in. And we know that interest rate is 0.04. So year two, if I didn't add any more money to that, that's going to be equal to our original balance plus your original balance times the interest rate, right? So at the end of year two, if you had a 4% interest rate, you would have $1,040. So that's what it's saying is every year. And it calculates that before it displays it to you. So it's already changed and added that balance whether or not you output it. So let's go look up at the pseudocode for that. So declarations, we have bank balance, interest rate, response of some sort, and your interest rate. And notice we capitalized all of that, and that tells us that it is a constant inside of our program. It doesn't change. We don't modify this value. So here we say, enter your starting balance and input bank balance. So again, we're adding a piece here because in all of our programs before, we just said input bank balance. We didn't go to the detail of saying, you're giving the client or whoever's using this program any information. So they put in a bank balance, so they put in that $1,000. Do you want to see your current balance? Input response. And now we say, so while response equals yes. So only if they put in a yes here. If they don't, it's going to come down here past the end while and say, oh, have a nice day. As long as they put in a yes, it's going to output bank balances, and it's going to tell you the bank balance out. It's then going to add a year's worth of interest. It's going to ask, do you want to see next year's balance? Get a response. If that response is yes, it's going to continue to input that. Otherwise, it dumps back out and says, have a nice day. So we don't have any clue. You may have somebody who wants to see what their bank account would be in 70 years. Click, 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 click. I'm typing yes every time. So that idea of a bank balance program. So notice here, we've just made it a little bit of a GUI, it looks like, but it's doing the same thing. Here's your bank balance. Here's your bank balance. 4% interest doesn't make it grow very big, though, does it? So this is just a very simple way we can do something with a loop. So a loop has to do a couple of things. If I don't have some way to check this every time and I just put that in a loop, I have to have some way out of that loop. So in other words, we initialize that loop variable up here. We control it and test it here. So that's what actually creates our loop. We alter it here, or have the ability to alter it. So same thing down here. We initialize it, we test it, and we have to have some way to alter it or get a different change. If I did not, it's just going to continue to loop over and over and over again. And we don't want that. Nested loops we're going to start on. And we'll probably start that one on Thursday. We'll talk about nested loops. So make sure you have read chapter 4 in your book. These loops are really the most powerful thing we're going to do with a computer. They allow us to do something interesting. So this week we also have, it'll come back up. Well, maybe we're not going to get back up there. There we go. So we have a test, and there is a program we're going to do. So there's a couple of questions just like last week, but there is also a program we're going to debug. Do not start on this until we have worked on how to do nested loops. So unless you've already seen this before, please wait until we start on that, or it will probably be very confusing to you. So make sure you read all about chapter 4. Take a look at those solutions, compare them to your own. Did you do something different? And one of the powerful tools in here is taking a look at examples that you and other students do and seeing if you can apply that and change what your own items are.